Okay, the first one we're going to talk over is a word problem where we have a perimeter of 80 and an area of 300. And this 80 over x is not right, but I could start with the area is 300, so that means this side times this side makes 300, right? So then this one must be 300 over x. Would you agree? Okay, good. So then if I do it this way, then I can make the perimeter formula. I'm going to have to use the area once and the perimeter once to make this work. The perimeter is 2 lengths plus 2 widths, and the perimeter is 80. And 2 lengths, the length I'm going to call the longer side. I'm going to call that the length. So 2 of those plus 2 of the widths, which are x. Now I have some bad news for you. You cannot use the calculator. No calculators on this test, so you can't graph both sides, see where they cross. Oh, you have to do algebra? Oh my gosh! All right, so it's good for you to know that because we are going to have a test on word problems. The next test you'll be able to use the calculators, but not this one. So how do you fix this if you can't use a calculator? You can. First thing I taught you at the very beginning of the year was how to clear fractions. How do we clear the fraction out of there? Multiply everything by what? X. Okay, so this becomes 80x. And the x being multiplied by this part just makes the x cancel out of the denominator. So what we're left with is 2 times 300, which makes 600. And the x is disappearing. Plus, what's 2x when you multiply it by x? 2x squared. Look at that, it's a quadratic. And we'll make sure that since you don't have a calculator, that we're not going to make these brutal numbers. All right, so then I'm going to move this over, and I'd have 0 equals 2x squared minus 80x plus 600. Now, I know that those are tough numbers, but at least what would be the first step? Try and factor it. Good. Can you see that they all have a 2 in them? All right, so let's take the 2 out. 0 equals 2, and then x squared minus 40x. Hey, all of them are half as big now. Yay. Now can I factor that last part? Again, on the test, you'd be able to. Either you're going to be able to factor it, or they're going to be much smaller numbers that you're going to plug into the quadratic formula. Okay, so if I want to factor, use quadratic formula. All right, so I'm going to see if I can keep on factoring this, though. Would 300 break up into anything? It's got to multiply to 300 and add to negative 40. So one will be positive and one will be negative. No, they either have to be both negative or both positive, so they must both be negative. So it would be 2 and then x minus something and then x minus something. Is there any way to make this work? 30 and 10 multiplies to 300 and adds to 40. Hey, I think you're right. All right. And then, final answer, 30 and 10. And what did we just figure out? There's 30 chickens and 10 cows? No. Well, what did we figure out? The dimensions. That was what we were trying to figure out, is the dimensions of this thing. This is 30. No, wait, that makes more sense to have this be 30, and this must be 10. All right, what were we figuring out here? We're figuring out x, right? What were we trying to figure out in the original problem? All right, here's another way to think of it. If this is bothering you that the answers are 30 and 10, it is true, by the way, this is 30 and this is 10. But if that's bothering you, would it make more sense to you to do it this way? I can pick x to be either of those two things and make it work. Let's say I pick x to be 10. If x is 10, look what happens here. 300 divided by 10 would be what? 30. See? That would work. Or if I decide not to make x 10, let's say I want x to be 30, well, what happens when I put the 30 in here? 300 divided by 30 gives me 10. So it's 30 and 10 no matter how you slice it. It's got to be 30 and 10. Okay, that'll have a perimeter of 80 and an area of 300. Yes, ma'am. What about the 2?
I thought you said like if there's a number in front of equals 0, it's not an x.
Okay, if we had this, then there'd be 3 answers. But when you just have a number here, there's no answer for that. That's not like a 0, okay? All right. If you think about it, too, didn't we have a squared in this problem? That tells you that at most there's going to be 2 answers, not 3. Yes?
What was the the algebra when we went from 80 equals 2 to 300 over x plus 2 into 80x equals 600 plus 2.
All I did is I took this and moved this over to the other side. Do you see that? Before that, okay. When I multiplied everything by x to clear my denominator. Do you get why I multiplied everything by x? Because there's x in the denominator. I multiplied everything by x, and that became 80x. When I multiplied this part by x, the x is canceled, and I had 2 times 300 is 600. And I multiplied that by x, and I got 2x squared. Thank you for asking. All right, that's a word problem. I can't solve every word problem that there is, but there's many kinds. You'll have to be able to handle them. There's some keys to it. Draw the picture. Label the picture. You're at some point going to use a pure form of a formula. If you're doing those three things, you have a decent chance. All right, let's talk mixture one last time just to make sure. Do you know the formula? Try writing it down. In fact, maybe you don't even have it memorized, but you know how to set it up. I'll give you one to set up. Just set this up. Let's say that you have 8 milliliters of 30% acid, and you're going to add some amount of pure acid until the mixture is 65% acid. See if you know how to set that up. Yes, ma'am. No calculators means no calculators. I'll show you what to do. It's not that bad. You can handle it. You can handle it. All right, so you'd say 8 times 0.3. Would you agree with that? Plus x times pure is what percent? 100%, so it's 1. Equals, mix is, well, I don't know how much there is total, but I kind of do. What do I put for the total?
1.
Not 1. 8 plus x is the total amount of stuff you're going to have, and then it is 0.65. That is a big, long equation that you should be able to solve. And we're going to give you numbers that are doable. Okay, so they're not going to be awful, terrible decimals. All right, so that, how many of you had it set up right? Raise your hand if you did. See, that's half the battle. Here's the other half, being able to multiply. 8 times 3 is 24, but it's decimal in there, 2.4. Can you handle that? You got to be able to do that much multiplying without a calculator. You don't get how to do 8 times 3? 8 times 3? Seriously? 8 times 3 is 24. Okay. Go back a notch just to, if I do 8 times 0.9, just ignore the decimal to start with and just do 8 times 9. What's that? 72. And then now you got to figure out where to put the decimal, right? How many decimal places were in the original problem? Therefore, you put in 1 decimal place and the answer is 7.2. Okay, let's say it was 32 times 0.2. Or actually, let's make it a little more complicated, 0.02. Ignore the decimals. It's just 32 times 2, which is what? 64. And now, where do I put the decimal? How many decimal places were in the problem? 2. So you put in 2 decimal places, zoop, zoop, 0.64. Can you handle that? All right. Okay, let's go back to this then. So now x times 1 is, of course, just x. Now this, again, these numbers will be nice enough that it won't be that bad, but 0.65 times 8 is doable. Just do 65 times 8. If you can't multiply, you are going to have a problem on this problem. 5 times 8 is 40. 6 times 8 is 48. 49, 50, 51, 52. And now I got to put in my decimal. How many decimal places did I have? 2. So I got to move it over 2 spots, 5.2. And then plus 0.65x. Are you really complaining about multiplying 8 times 0.65? You can do that. All right. And now we're going to take these decimals and simplify it down a little bit, I have x's on both sides. I got to subtract 0.65x. Hey, you might want to practice this. This is the type of question you will have to do tomorrow, so try this. If you don't know how to do it, you got to at least know that. Sorry, Monday. Yeah. That's a 1x minus 0.65. If it helps, sometimes think about money. It's like a buck minus 65 cents. 35 cents. Now I'm going to subtract. Minus 2.4. Minus 2.4. And again, if it helps, think of it as money. $5.20 minus $2.40. You can do that. So it's like $3. I'm going to take away the 2 first. And my 5.2, and I take away 2, would be 3.2. So it's like 3.2 minus 4. See what I did there? 0.4, sorry. So it's like $3.20 minus 40 cents. If I take off the 20 cents, it'll be just down to 3. And now it's $3 minus 20 cents. This is how my mind works through it anyway. If I take $3 minus 20 cents, it's going to be what? 2.8, $2.80. All right. And now I have 0.35x equals 2.8. And if we get you this far, then I'd be okay if you have a nasty decimal in your final answer, not the early on, but in your final answer like this. I'd have been okay if you'd have left it like this. That'd be okay. I wouldn't expect you to be able to divide 2 nasty decimals. Okay? All right, moving on to, I was asked about a question like number 1. I'm going to give you one of these. 1 over x plus 2 plus 1 over x minus 3 is equal to, let me see what number 1 was like. Excellent. In the first, outside, inside, last. This is like number 1. It's not the same as number 1 on your worksheet, but it's a lot like number 1. You can handle doing number 1 all by yourself. All right. So try this one. You should know how to multiply everything by. Give it a shot. And if we're done with this, we'll still have a half an hour yet to work in class, and that'll be good. So finish this puppy up. Rapido. A lot of stuff's going to cancel. I hope you notice that this part right here is really something that can be factored. If it can factor it. And then you'll notice, oh, it's really that and that put together. AL, give it a shot. That whole problem that I just put on the board? No. I see. At least I know why you thought you were done. That's good. It was like number 1. That's good. Well, then, I was about ready to do it anyway, so why don't you come on up and do it? Okay, well, then just tell me what to do. Yep, I'm going to do that everywhere. X plus 2, x minus 3, x plus 2, x minus 3. And then what happens over here? Perfect. X minus 3 is all you have left. Then what? Good, and then I got x plus 2 times 1, which is just x plus 2. And then what happens? So that cancels that. Perfect. Equals 5. And this one doesn't even have a quadratic in it. So this is a really simple one. 2x minus 1 equals 5. Add 1 to both sides. 2x equals 6. X equals 3. Raise your hand if you had that one right. Okay, awesome. Oh, slow down. Okay. All right. Okay, I wanted to give you a lot of work time, so if I stop now, I will be able to give you a lot of work time. So, any last questions on this? All right, a question is about one like letter I. All right. I think the best thing I can do for you on that is to actually do letter I for you. Okay? So everybody take a look at the worksheet now. Letter I. Did I assign that last night or not? Okay? And if you've already done it, you can check and see if you did it right. If you haven't done it yet, feel free to follow along. Letter I. It is, and by the way, if you're done with I and you want to work on the other part of the worksheet, go ahead. You can ignore me. If you're already positive you did it right. Okay, x minus 5 on the top, x plus 2 on the top, and an x minus 3 on the top. That was already factored, so I'm not going to even try to factor it. X minus 1 squared. Now, could you break that up into two things? Yeah, you don't have to. Might be smart, but you don't have to. And then there's an x squared plus 2, and some people will try to factor that, and they'll be wrong. You're not supposed to factor that because you'd have to actually use imaginary numbers to make it work, and you don't want to go there. All right, so does anything just cancel? No. So then this kind of problem, when it says greater than or equal to 0, you need a number line for it. And you got a bunch of important points on that number line. And some of them are 5, and -2, and 3. That's for the top. And those are all what's? Zeros. They're all Z's. The top things give you zeros. The bottom things give you what? U's. On the bottom, the 1, if I put in a 1, do you get that they would crash this whole equation? Because that would become 0. 0 times anything is 0. The whole bottom is 0. That's not good. Okay, so 1, which is right here, is not a 0. It's a U. And then here a lot of people get confused and they think something is going to make that equal 0, and you can't make that 0. And therefore there is no important point to put on the number line for that. All right, so now I got all my important points, and I got the Z's and U's above them, and now I just need to test the regions, and this is the most important part. You will have questions like this, and many of you will screw up testing your zones on here, so be careful. So I'm going to test a 6. Test that zone. 6, 6, 6, 6, 6. Positive, 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 positive. And by the way, since that's squared, it's always positive. Don't let me ever think it's negative. And that's positive. Everything's positive, so it's positive. Does that necessarily mean it works? No, not until I test this. Are positive things bigger than or equal to 0? Yes, so that gets a smiley face. So that zone from 5 to infinity is going to work. All right, next I'm going to test some other number, like 2, or how about 4? All right, so I'll put in a 4 everywhere. A 4, a 4, a 4, a 4, and a 4. And this will be negative, positive, positive. I better start keeping track of that somewhere. Negative, positive, positive. And on the bottom, it's positive, positive. So there's only one negative in the whole thing. So what is it? Negative. That's negative. That one was positive and it worked. That one's negative and it doesn't work then. The idea? What's the answer? You want me to finish the whole thing? I can finish the whole thing. Or would you agree it's between 5 and infinity? And will it work at 5? That's an important point. Is it like this, 5 comma infinity with a bracket? Or is it like this, 5 comma infinity with a parenthesis? Does that 5 work or not? Look at this. This is the key to whether an individual point will work or not. I know you're doing math, but I can't do it with you turning around and talking. So they turned right direction at least. Okay, so this is greater than or equal to, is 5, a 0, yeah, it's got a Z there, is 0 greater than or equal to 0? Yes, 5 is greater than or equal to 0. So which one is it? Is it going to work or not? So therefore, if it works, it must be that one, not that one. Earlier than 5? I didn't say that. I just said this zone that we know works, right here. That zone works and 5 works too, because it's a 0. and zeros in this problem, because it says or equal to, are going to work. Yes, ma'am.
Okay, so in the zone between -2 and 1.
Yes. In this little zone here, you tested 0. Okay, good. So let's,
0 make the bottom crash.
hold on. Let's test 0. I got to see if it makes the bottom crash or not. So let me get rid of this stuff. Does 0 make the bottom crash is a good question. Oh, poop. I deleted that. There we go. There we go. You thought it made the bottom 0, but it doesn't actually, right? Okay. So I just still need to finish this because people at home don't necessarily know what I'm talking about. If I put in a 0, negative, positive, oh, I can't tell if that's a negative there. So negative, positive, negative. So I go negative, positive, negative. And the bottom, it's positive because that's squared. That could very easily get you, and I bet that's what got you, isn't it? Didn't notice that. Okay, so that's positive and positive on the bottom. So there's only 2 negatives in the whole thing. So that means it's all positive, so therefore it's positive, and therefore it works. And if it works between -2 and 1, I have to figure out whether the -2 works or not. It's a 0. Do zeros work in this problem? Yeah, because it says or equal to 0 right there. All right, so it works at -2 bracket to 1, and 1 does not work because it's a U, and U's never work. Did anybody test this end spot? Does it come out negative? If it comes out negative, then it won't work. All right, good. How about the spot between 1 and 3? Did anybody test 2? Did it work or not? Does 2 work or not? Just going to double check it quick. Negative, positive, negative. So it's positive on top over positive, positive. Yep, it's positive. You're right. So it works in that little zone between 1 and 3. 1 does not work, so it's going to be 1 to 3, and 3 does work. Bracket on the 3. So there's your final answer. A U in between here and a U in between here, and it's all of that. It's all about testing the intervals. Okay, well, I don't feel too bad that I spent 7 minutes on that because it was part of your homework at least, and you didn't. I told you didn't have to pay attention to me during that time. So the rest of the hour is work on the rest of this packet and ask me questions individually time. Okay, Monday is the test, and that's all I have for the video for today.